Welcome to GrayYeon We are asked to solve this problem. We have this triangle ABC, and inside this triangle BC are the diagonals. The two segments D and CD, and they have a 45-degree angle at point D. And this is actually an isosceles triangle for the triangle EBC, and the length of the uh, segments AD is 2 and BD is 4. And we are required to find the area of this blue region. Okay, so since we are interested in the uh, area of this blue triangle, so we can find this base or the segment EB, the length of this. So we can label this as Y, and we label this uh, the height of this triangle from D to us by a line. The height is D from D by a line that is perpendicular to segment CE. So we call this as H. Okay, so we label this perpendicular point to be F, and we isolate this triangle FDB. So this is D, and this is B, and this is F. And since this is a 45-degree angle, okay, so this should be also a 45-degree angle. And if that is the case, we have two 45-degree angle and a 90-degree angle. Then this triangle is an isosceles right triangle, also same as ABC, which is an isosceles right triangle. So this will be H also. And therefore, we can find the value of H by Pythagorean theorem. So H square plus H square is equal to 4 square, or 2H square is equal to 16. So divide both sides by 2. So you have H square is equal to 8. So if we get the square root of both sides, so H is equal to, this is a 2 cube. And for if we get the perfect square only, take it outside. So we have H is equal to 2 square root of 2 units. Okay, so next is we focus on the angle. So we can label this angle at D as alpha. And if that is alpha, then this angle here, so next is we draw this horizontal line from D until it becomes intersecting with this segment AC. So let's call this as point G, and this should be perpendicular. So okay, so next is since this is a horizontal line GD, so this should be also 45 degrees. Okay, and if that is 45 degrees, then we can label this if you focus on this segment AB, so they have these several angles, the 45-degree angle, this alpha, and this 45. So the rest, this portion, we can call this as beta. And as you can see, 180, so 180 is equal to 2 times 45 plus alpha plus beta. So this is 90. So 180 is equal to 90 plus alpha plus beta. And 180 minus 90 is 90. Okay, so this is alpha plus beta. So this will be our setup. So we set that alpha plus beta is 90, or they are complementary angles. Okay, so next is we focus on this triangle GDB. So one angle, this is a right triangle, and one of the smaller angles aside from this 90 is beta. And so this other angle should be the complement, and that is alpha. And if you notice, this is also a 90 degrees at C. So this angle should be a beta because it needs to be a complement of this angle alpha, because it is an isosceles right triangle and this angle at C is 90. Okay, so next is we focus on this exterior angle of triangle, this triangle CDE. So this is a triangle. So the interior angle, I mean these two angles, this exterior angle should be the sum of this beta and 45, the two remote angles. So this becomes beta plus 45. Okay, so next is we focus on this whole triangle ABC. So this is A, this is B, and this is C, and this is the 90-degree angle, and this is 6 units, the hypotenuse. So we try to find the length of AC. So and since this is an isosceles right triangle, this is 45 degrees given to a 45. So let's call the length AC as x and this BC as x as well, because they have the same lengths, because being an isosceles right triangle. So x squared by Pythagorean theorem plus x squared is equal to 36. Okay, so we have a 2x squared is equal to 36. So dividing both sides by 2. So we have a x squared is equal to 18. So if we get the square root of both sides, so we just simply write this to be this 18, I mean, to be uh, 3 square times 2. So square root of that. So 3 square being a perfect square, so we can take it out of the radical sign. So this becomes 3 square root of 2. So x is equal to 3 square root of 2 units. Okay, so next is I have isolated this triangle ACD. So and BED. So notice that they have the same interior angles. So they have both alpha, a 45 degree, and this beta plus 45. This is beta plus 45. So, and also we have calculated the length of AC, which is 3 square root of 2. Okay. And notice that from this pair of sides, given sides, we can calculate the length of EB or Y. So this is EB by similarity, because these two triangles are similar, having both of them the same set of angles. Okay, so let us focus on the sides of these two triangles that is opposite the alpha, and this beta plus 45 degrees. Okay, so for the triangle ACD, let's focus on BED, I mean. BED, we can make a ratio on the sides opposite alpha and beta. So for BED, so the side opposite of alpha is y, and the opposite of beta plus 45 is 4. It is equal to a ratio of these sides of this bigger triangle, the ACD. So corresponding to y, which is the opposite of alpha, it is 2, and corresponding to 4, which is opposite of b beta plus 45, it is 3 square root of 2. So to get to y, we just need to cross multiply. So y is equal to 4 times 2 over 3 square root of 2. Okay, so we can write this, y is equal to 4 times this square root of, this 2 on the numerator can be written as square root of 2 squared all over 3 square root of 2. So we can cancel this, and this cancels out. So it becomes 4y is equal to 4 thirds square root of 2 units. Okay, so now for the final step, so for the area of triangle BED, the blue area we are looking for, it is 1/2 times the base times the height. So, but the base is actually a EB, so 1/2 times the base, which is EB. So, but EB is equal to Y. So, Y times the height, which is H. Okay, so it's equal to 1/2 times Y is, as we have gotten earlier, it is 4 thirds square root of 2 times the height, which is 2 square root of 2. So if we combine this square root of 2 times square root of 2, this becomes 2. And this cancels out with this on the denominator. So we have now here to multiply this 4 and 2 over 3. So area BED is equal to 4 times 2 is 8 over 3 square units. And that is our answer. So thank you for watching until the end of the video. Please like the video if you like our solution, and don't forget to subscribe to the channel and hit the bell icon so you will be updated for more math videos like this. Thank you. Bye.